Acids and bases, pH. Objectives. Identify the acidity or alkalinity of a solution by its pH value. Calculate the pH of a solution given its hydronium ion concentration. And finally, compare the hydronium ion concentrations of solutions by their pH values. pH. Although we can measure the hydronium ion and hydroxide ion as molar concentrations, it is more convenient to describe the acidity of solutions using the pH scale. What is the pH scale? The pH scale is a measure of the hydrogen ion or the hydronium ion concentration of a solution. The pH scale extends from 1 to 14. From 7 to 1, it's acidic, and from 7 to 14, it's basic. 7 is neutral. For an acid, the hydronium ion concentration is greater than the hydroxide ion concentration. For a base, the hydroxide ion concentration is greater than the hydronium ion concentration, while for a neutral solution, the hydronium ion concentration is equal to the hydroxide ion concentration. Acids are substances with pH values less than 7. Neutral substances have pH values equal to 7. For example, pure water or sodium chloride dissolved in water. Bases, on the other hand, are substances with a pH values greater than 7. The closer you are to a pH of 1, the more acidic the substance will be, while the closer you are to a pH of 14, the more basic the substance will be. Practice question 1. What are the relative ion concentrations in an acid solution? More hydrogen ions than hydroxide ions. An acid solution contains more hydrogen ions or hydronium ions than hydroxide ions. A neutral solution will have equal number of hydrogen and hydroxide ions. Calculating the pH of a solution. When we relate acidity and pH, we're using an inverse relationship, which means when one increase, the other decrease. When an acid is added to pure water, the concentration of hydronium ions increase, but its pH decrease. You go closer to 1. When a base is added to pure water, it becomes more basic and the pH increases. The formula to calculate pH is negative log the hydronium ion concentration. For example, if you were to determine the pH of a solution with hydronium ion concentration of 1.0 times 10 to the minus 2 molar, pH is the negative log of the concentration of the hydronium ion. So it's a negative log of 1.0 times 10 to the minus 2, which is negative 2, which is 2. The pH of this solution is 2. Practice question. What is the pH of a 0.001 molar HNO3 solution? The negative log of 0.001 is 3. Change in hydrogen ion concentration with pH change. If you were to compare the hydrogen ion concentration when a solution pH changes from 7 to 6. Here we have a pH of 7. A pH of 7 has 1 times 10 to the minus 7 hydrogen ion concentration. A pH of 6, on the other hand, has 1 times 10 to the minus 6. There are more hydrogen ions in a substance with a pH of 6 compared to a pH of 7. How much more? 10 times. A solution with a pH of 6 has 10 times or tenfold more hydrogen ions than a solution with a pH of 7. Other values for different pHs can also be shown. If we were to compare the hydrogen ion concentration when a pH solution changes from 6 to 5, here it also increases by a factor of 10. A solution with a pH of 5 has 10 times or tenfold more hydrogen ion than a solution with a pH of 6. If you were to compare the hydrogen ion concentration when a solution's pH changes from 7 to 5. Here we are going from 7 to 6 and then from 6 to 5. It increased by a factor of 100. A solution with a pH of 5 has 100 times, 100-fold more hydrogen ions than a solution with a pH of 7. A misconception alert. The concentration of hydronium or hydrogen ions does not increase by 20. Instead, it increases by 100 when the pH decreases from 7 to 5. If you were to compare the hydrogen ion concentration when a pH changes from 9 to 6. So now we're going from 9 to 8, 8 to 7, 7 to 6. We increase in hydrogen ion concentration by 1,000. A solution with a pH of 6 has 1,000 times, 1,000-fold more hydrogen ions than a solution with a pH of 9. Another misconception alert is it does not increase by a factor of 30, but by a factor of 1,000 when it goes from 9 to 8 to 7 to 6, from 9 to 6. Practice question 3. What is the pH of a solution that has a hydronium ion concentration 100 times greater than a solution with a pH of 4? Two. If we have a pH scale from 1 to 14, and initially we are at 4, if we were to increase 100 times, we would have to go towards the low end of the scale. And every time you go from one number on pH value, you increase by tenfold. So from 4 to 3 is 10. From 3 to 2 would be 100. So our answer is 2. When you go from a pH of 4 to a pH of 2, the hydronium ion concentration increases by 100. Practice question 4. When the pH value of a solution is changed from 2 to 1, the concentration of hydronium ions increase by a factor of 10. Here we are going from a pH of 2 to a pH of 1. It's increasing in the lower direction. It's increasing by a factor of 10.